For decades now, our entire digital world has rested on a pretty fragile foundation, single point of failure computing. One node crashes, the whole system breaks down. But today, that reality fractures. We are officially entering the era of resilient, multi-substrate computing. We're talking about systems that don't just survive stress, but actually mathematically prove their own correctness across entirely different types of hardware.
Welcome to The Explainer. Today, we're breaking down a historic computing milestone achieved on June 28, 2026. This isn't just another story about computers getting faster, folks. It's about computing becoming fundamentally bulletproof. We're going to explore exactly what happened today and why it completely changes the very fabric of how we build technology.
Here's our roadmap for today. First, the zero leakage milestone. Second, decoding multi-substrate computing. Third, the shift from debugging to proving. And finally, business, defense, and AI. Let's get right into it.
Section 1. The Zero Leakage Milestone. Peyton and Perrine's Breakthrough.
Okay, so what actually happened today? Well, Peyton and Perrine Technologies Corp. released evidence documenting a verified zero-leakage pipeline completion for their eMan++ compiler. And this isn't just PR spin. It's backed by a stable semantic proof hash, essentially a mathematically unbreakable receipt recorded directly in the system's manifest. Every single log transcript for this build ended with the exact same statement, zero leakage pipeline complete. It proves the system is incredibly disciplined, giving us a traceable, repeatable verification result, not just some one-off demo.
And get this, the result was a perfect 5 out of 5. The system's mathematical summary explicitly proved 0 divergent runs and 0 missing runs. For tech teams out there evaluating platforms like Cove, this event proves that the system is built entirely around absolute, provable control.
Section 2. Decoding multi-substrate computing. Beyond hardware lock-in.
So, what does it mean to be 5 for 5? Well, the eMan Plus build successfully ran an identical, verified core design across 5 radically different hardware environments. We're talking classical computing, what we use every day, running right alongside neuromorphic, photonic, biological, and even quantum substrates. The build behaved uniformly and produced the exact same semantic value across all 5. It didn't fail, it didn't leak, it just worked.
This completely shatters the concept of hardware lock-in. Instead of writing code for one specific machine, you design a verified core once and it targets multiple hardware substrates. It's truly architecture-agnostic computing, and the flexibility this provides in terms of cost, performance, and overall resilience is just absolutely massive.
Moving right along to Section 3, from debugging to proving, the paradigm shift.
Think about how we used to build trust into our infrastructure. The old way of building software was literally run and debug. Deploy it, wait for things to break, and patch them in a panic. But this zero leakage milestone ushers in the new way. Prove and verify. The system mathematically proves it will behave correctly before it is ever fully deployed.
To quote the release directly here, correctness is being demonstrated through hashes, manifests, and equivalence checks rather than only through manual inspection. Trust moves so much earlier in the pipeline now. We're fundamentally turning software from a loose script into a rock-solid engineered contract with guaranteed properties.
And that brings us to Section 4. Business, defense, and AI. Real-world impacts. Let's unpack how this solves some massive problems.
Pillar 1 is business operations. For enterprise decision makers, especially those dealing with finance, SaaS, or heavy compliance, this is a total game changer. It translates directly to selling trust.
Because, let's be real, the biggest cost in modern computing isn't server space anymore. It's mistakes and outages. This technology delivers significantly lower operational fragility. Systems verify their own behavior and recover locally. That means reduced outages, less data loss risk, and fewer expensive manual interventions. Software architecture is finally behaving like engineered infrastructure.
Pillar 2 takes us straight to defense. Out in contested environments, static perimeter control is totally obsolete. Today, it's all about speed, survivability, and adapting in real time.
With self-healing mesh architectures, defense networks become living infrastructure. If a node gets knocked out, the system automatically routes around it. They keep functioning after damage. Plus, having verified software massively reduces supply chain risk. The advantage really shifts to whoever has the best real-time autonomous response.
Finally, Pillar 3, AI. And honestly, the global impact here kind of dwarfs the rest. This milestone is the exact thing that pushes AI agents beyond just being isolated chat interfaces.
We're looking at agents with memory and built-in mathematical safeguards. Because we have proof-backed deployment, we get much safer multi-agent coordination. You can actually safely unleash these agents in high-stakes environments because their actions are provable, which paves the way for true human-on-the-loop governance.
It all boils down to this right here. Computing shifts from being a passive tool to being a more autonomous, resilient, and verifiable infrastructure layer. Ultimately, we are witnessing the birth of systems that can keep working, mathematically prove what they just did, and self-heal when things inevitably go wrong.
So as our infrastructure gains this unprecedented level of autonomy and verifiable trust, it leaves us to ponder a massive shift in how we interact with technology. It brings us to one final, critical question. How much is society willing to let computers decide on their own when software becomes a provable contract? It's a fascinating future for sure. Thank you so much for joining me on The Explainer today.